Yeah, so what we've got here is two yield maps off of the same field of successive seasons, and on the left we have a barley yield map, and also wheat yield look very similar patterns to this, and we have a canola yield map on the right. And the colour scheme works that the reds and yellows and oranges are generally medium to low yields, and the greens to blues are sort of higher yields. So we can see here that with the barley yield map you've got this large, low yielding area in here. But when we move the canola yield, the opposites actually occurred, and this has been the most productive part of the paddock in that year. And then conversely, up in this edge along here, the canola obviously didn't enjoy this growing environment running down through this seam, but when we look at the barley yield, it has actually enjoyed that growing environment and has produced the most profit. So this sometimes is called flip-flop, and often can lead to some frustrations about moving forward with precision ag when you've just got yield maps to work with, because if this type of variability is going to occur, it makes it very difficult to estimate what you should be doing with your inputs to try and work in harmony with the productive capacity of the field. So to try and move forward with that, we can just go look at some soil sensor maps on how that might allow us to understand this a bit and make some sense. So we'll just bring up another map of the field, and so what we're going to do here is we're just going to take an EM map and overlay it, and I think fairly quickly you can see that this very low EM value here, this big region here, is corresponding with this low yielding barley and with the high yielding canola. And then these fringes around here, which tend to be higher EM, which is likely to be heavier soil, a bit more clay, but possibly a little bit of subsoil constraints as well. But the canola hasn't done near as well in those areas, and the barley's thrived pretty well. So if we also drag over the top a radiometrics potassium map, again we still have some sort of correlation between what the radiometric sensor's picking up as a different soil type in this corner of the field and then running around the edge. So the third one we can look at is thorium, another part of the gamma radiometric spectrum, and again that's sort of showing some patterns, probably not quite as strong as the EM and the radiometrics potassium, but still showing some patterns which correspond to the yield variability. So what we can sort of look at there now, instead of saying, well, I don't understand why my yield is varying between canola and barley, we can see that it's very much linked to soil type. So if we understand the agronomic requirements of canola and barley, and then we go and investigate these soil types here, we can start to build an understanding of why the barley tends to have lower yield there and why the canola is high. And once we have an understanding of that through soil testing and the soil properties, then we can start to set target yields and start to aim for a different variable rate program going into cereal as we would for canola. So the next thing we'll just look at here is a little bit of what our soil zones may look like. So up on the left here, we've combined the soil sensing layers into 4 potential soil classes, and then what we've done is we've taken the canola yield and we've looked at the performance of canola over a couple of seasons in those soils. So you can see in these reds and yellows here, as that's where our yield is lower, and the greens and the blues, the yield is higher. But then when we look at the barley yield, we've got quite a different situation where, if you remember, these two zones were the lowest yielding with canola, but they're the highest yielding with barley. So then we can start to sort of understand where our soil type boundaries should be and what sort of management we should target between them. So what started off as perhaps a possibly confusing and frustrating scenario here with your two very different yield maps can actually be interpreted and unlocked and give you the ability to move forward by using soil sensing data.